Okay, hey guys, welcome back to Chem Quiz Online class. We are still on our 30 days challenge. In this video, we are going to talk about Le Chatelier's principle. How change in concentration affect the equilibrium position, how change in temperature affect the equilibrium position, and how what change in volume and pressure affect the equilibrium position. So you will not stick to the end of this video and take down every single thing. So the question will be, what is Le Chatelier's principle? Le Chatelier's principle states that when a stress is imposed into a system at equilibrium, the system will shift in order to what, to nullify or reduce the effects. That's called Le Chatelier's principle. So we are talking about chemical equilibrium. Then we are talking about what equilibrium system. So the question will be, what is equilibrium system? So equilibrium system occur in a reversible what reaction. In a what reversible what reaction. You understand? So when a reaction is reversible, there's every tendency that reaction meets what equilibrium. So what is equilibrium? Equilibrium is that state in which what the forward reaction equals the rate in which what the rate of forward reaction equals the rate of a backward what reaction at a certain what temperature. That's what we call what equilibrium. And this type of equilibrium is called what dynamic what equilibrium. Now the main reason why it's called dynamic equilibrium is because there's a movement, but the movement for the backward reaction is at equal what rate. Do you understand? So every reaction have their own equilibrium system, and that equilibrium system have a specific temperature in which what the reaction occur. Do you understand? In which what the equilibrium will occur. So yeah, A is what is the reactant. A is what is the reactant. Now moving to what to the product. To the product is okay. To the product. Then the product also what move back to the what reactant. So here we have forward reaction, which is what that is the reactant move forward to the product. Then here we have backward reaction, that is the product move back to reactant. Do you understand? So it get to a point where the reaction what reach equilibrium. The rate of what forward reaction because what rate of what backward reaction. What does it mean? It means that the rate at which reactant is the reactor what produces product is also the same rate in which what the product is also decomposed to what form backward the reactant. And every reversible reaction love their equilibrium states. So imagine here we have forward reaction and backward reaction are the same. How does change in concentration affect the equilibrium? How does change in temperature affect the equilibrium? And how does what change in volume and what pressure affect what the equilibrium? So you really want to pay close attention here because it's very what confusing. I want to explain it step by step now for you to understand this here. So we're going to look at what change what in concentration. Let's look at what change in concentration. We talk about change in what concentration. Right there. So when a reaction is at equilibrium, now you can either what change, that is, you can either increase the concentration of the reactant or product, or decrease the concentration of the reactant or product. So the question will now be, when you increase the concentration of the reactant and product, where will the sign shift to? And when you reduce the concentration of the reactant or product, where will the sign shift to? So this is a little bit confusing, but I want to show you a simple system or method or step you can what follow in order to get this thing easy. Now, what I want to understand here is that an increase in concentration at one point will cause the reaction sign to move to the opposite side. What do I mean? It means that if I increase the concentration of the reactant, the reaction will move to the product side. Do you understand? And if I increase the concentration of the product, the reaction will move to the reactant side. So that means that an increase in concentration at one point shift the equilibrium position to the opposite side. What I mean that an increase in what concentration of what reactant we shift the equilibrium to the product side. Do you understand? So it means that it's going to what it means that it we favor forward what reaction. Do you understand? It's very important here. It will favor what the forward what reaction. So when you increase the concentration of the reaction what will move forward, creating more of what of the what product. I make sense here. If for example here we have A move to what B. So if you should increase the concentration of this reactant here, it will shift what to the product side, right? Creating more of what of the what product. So you're going to what favor what forward reaction or shift toward to the right. Here we have right, left. Do you understand? So there are different ways you can what make your feel or say it. An increase in concentration of products of what products we shift the equilibrium to the reactant side. Do you understand? So it will favor backward what reaction. It will move what backward. Favor backward reaction. You understand? If you want favor what backward what reaction. I make sense here. So if you should increase the concentration of this product side here, it will shift back to the reactant. Do you understand? So this is what an increase does. An increase in concentration at one point we shift the equilibrium position to the opposite side. So when you increase the concentration of the reactant, the reaction will move towards the product. When you shift the concentration of the product, the reaction will move back towards the reactant. Do you understand? Look at what a decrease in concentration. So you can that a decrease in concentration at at one point we shift the equilibrium position to the same side. Idea. To the same what side? To the same side. Idea. It means that if you decrease a point, the gas will move to that point here. So it means that a decrease in concentration of what of reactants of reactants, we shift the equilibrium side to the reactant side. We shift the equilibrium to the what reactant side. It's okay. We shift the equilibrium to the reactant side. Do you understand? So the second one, a decrease in concentration of what products we shift the equilibrium position to the product side. It's okay. So it's very easy here. If I decrease reactants, it will move backward. If I decrease products, it will move forward. Do you understand? So a decrease favor the same side. Do you understand? So when you decrease the reactant, move to the reactant side. When you decrease your product, move to your product side. Do you understand? So let's look at what an example. So let's look at what this first question that will explain the concept for you very well. So that consider what the equilibrium reaction, the Abba process. How does change in the following concentration affect the equilibrium position? There's an increase in concentration of NH3. Now here we have decrease in concentration of N2, increase in concentration of H2. So let's get into it. Now remember that an increase in concentration at one point will cause the reaction to move to the opposite side, right? So NH3 is what is the product. So when you increase the concentration of the product, where the reaction, where will the equilibrium side move to? Move toward to the what backward what reaction. Favor the what move toward to the reactant side. So solution. Here we say that A, an increase in concentration of NH3 An increase in concentration of what? NH3 will move the equilibrium position to the reactants reactant side. I there. I there. So it will favor backward reaction. It will favor backward reaction. It's okay. It will favor what backward what reaction. Do you understand? It will favor what backward reaction. That is, when you increase the concentration of NH3 here, what happens to the concentration of these two here? The concentration of these two will what will increase. Do you understand? So that is the meaning. So B, a decrease in concentration of N2. You get. So B, a decrease in concentration of N2. So here we have what N2. Now when you decrease N2, when you decrease what N2, what will the action shift to? Now remember N2 is part of the reactant. So we are talking about the reactant side. So you are decreasing what the reactant side. But you are picking one of the reactants. So if you decrease the reactant side, which N2, where the reaction moves to? Remember I told you that a decrease in concentration of the reactant will cause the reaction to move to the reactant side. So when you decrease nitrogen here, the reaction will shift backward to create more so that it will be lost. You get. So you're gonna cause decrease in this one here, right? Because when you remove this one here, this one what react fast to create one here. So the concept of this one will go to decrease. You get. So you're gonna decrease in order to want to produce so that is being what lost. Do you understand? So a decrease in concentration of what? Of N2, which is what the reactant. We move the equilibrium position to the reactant side, to the what reactant side. So a decrease in concentration of N2 will move the equilibrium position to the what reactant side. So what happens to the concentration here? Now the concentration of this one is going to decrease, while the concentration of this one is going to what increase. So if I ask me now, what I'm saying is that because you decrease one here, the concentration of this guy is what going to increase. So yeah, it's going to decrease. Why is it going to what to increase? You understand? So that is the answer. So that is it. So let's move on to C. Increase in concentration of N2 of H2. So what happens when you increase this guy here? So N2 C. So when you increase H2, where will it shift to? It's going to what shift to the product side, right? So an increase in H2, which is one of the reactant, will what shift the reaction to the what product side. So an increase in concentration, of what of H2 will move the equilibrium position to the product, to the what product. It's okay. That is the answer here. You understand? It means that when you increase one here, this one is going to increase. Why is one going to what decrease? The concentration is going to increase. Now, why this one is going to what to decrease? That is the what mean. So that is for what change in what concentration. You get. So if you understood, leave at the comment section that you actually what understand what I have done. So let's get to the next one. Change in what in temperature. Let's look at what change in what temperature. How does change in temperature affect what the equilibrium position? Now this is a little bit confusing because you need to understand what called exothermic work and endothermic. So now when it comes to temperature Therefore, you must understand what we call exothermic. Exothermic what? You must understand what it's called exothermic what? Exothermic reaction and endothermic reaction. It's okay. Exothermic what reaction and endothermic what reaction. So we are going to take the first one here. Exo. Now, in chemistry, now when a reaction occurs, now there are two things that can happen to it. It can either be absorbed or given out. Do you get that? So when we talk about exothermic reaction, exothermic reaction, it means that it is lost. Do you get that? It is what? It means that it is lost by the what? System. Right there. It is what is lost by what? By the equilibrium or by the system. You understand? So now whenever it is lost or given out, what happened here? Whenever it is given out, what should come to your mind is that delta H is always what? Negative. Delta H is always what? Negative. Do you understand? So in an extreme reaction, it is lost or it is what? Is given out. So now whenever it is given out, delta H is what? Is negative. Do you understand? Another way you can see it in the exam, you can either see like delta H is less than 0. Do you get that? So these two are the same. Delta H is equals what? Minus is negative, or delta H is what? Less than 0. Do you get that? So now let's imagine we have this reaction. Let's imagine we have what? This reaction. Here we have A move to what? To B. And they say what? My delta H is what? Is negative, is less than what? 0. Do you understand? Now, because delta H is less than 0, we are talking about what? The exothermic what? Reaction. Do you understand? And remember you are talking about the exothermic reaction because delta H is less than 0, usually the enthalpy, the heat content of the system. Now, it will be treated as what? As a product. It will be treated as a product. So when you have something like this, you have to rewrite the stuff. Do you understand? As this. Because it is given out, it is just like what? As a product. So it's going to be A moves to B plus what? T. Do you understand? So temperature will always be here. Now, because when I talk about exothermic what? Reaction, so temperature will what? Be on the what? On the product side. So the question is this: if temperature is on the product side, how does it relate to what? To change when you reduce and when what? It increase. Do you understand? Imagine this temperature is just like what? A concentration. Now, when we take concentration, we say that an increase in concentration at one point will cause the reaction to move to the opposite side, right? So imagine here we have B. B is what is the product here. If you increase the concentration of B, which was the product, where will it shift to? I'm asking you. Where will it shift to? It will shift to what? To the reactant side, right? So an increase in temperature. Do you get that? An increase in temperature. Now, because temperature is the product side. When you increase temperature, now I'm asking you, where will it go to? It will move toward to the reactant side. Do you understand now? So you can see that an increase in temperature, right? In exothermic, in what? In exothermic what? Reaction, we cause or we shift the equilibrium position to what? To the what? Reactant side. We shift the equilibrium position to the what? To the reactant side. It's okay. To the what? To the reactant side. That is it. You understand now? So what about if you decrease concentration? So you can see that a decrease in concentration. Sorry. What about decrease in temperature? So you can see that remember when you decrease B, right? Where will you shift to? Remember that a decrease in concentration at one point will cause the reaction to what? Move to the same side, right? So when you decrease the concentration of B, where will it shift to? It will shift to what? To the product side, right? temperature here is treated as reactant, so as product. So when decrease the temperature here, where will it shift to? It will shift over to the product side. Do you understand? So you can start a decrease in temperature in what? In exothermic thermic what reaction. We shift the equilibrium position. We shift the equilibrium position to the product side. Do you understand? That is it. So there are things you need to take down inside your note. It's very, very what important. Hope you are following. So if you are not subscribed, please endeavor what you subscribe to the channel. And if this video is helpful, make sure you leave it at the comment section that this video is what is helpful. I really want to hear from you. So we are done with what exothermic reaction. Let's look at what endothermic reaction. Endothermic. Endothermic reaction. Endothermic what reaction. Now, what about endothermic reaction? That is, it is absorbed, and or it is gained, right? So you can talk about it what gain, or it absorb. And whether it is gain, delta H is always what positive. It's always what positive. Even that my delta H is what is greater than what zero. That is meaning. Delta H is what is greater than what zero. Do you understand? So if for example here I have something like this, I have this reaction here. A move to what B, and I have delta H to be what? To be greater than what zero. It's okay. Although you may see that plus any of the what value of delta H should be given, right? So if delta H is what is greater than zero, what happen here? It will be treated a lot as, because it is absorbed. It is what? Absorbed. That is, it is gain. So whenever it is gain, temperature will be treated a lot as reactants. So you can write this one to be like this: A plus T giving you what? B. Can you see that? Do you understand that? So here we have A plus T give you what? B. So what will happen when you increase the concentration of T? And what will happen when you decrease the concentration of T? Please leave at the comment section. I want to hear from you. What will be the equilibrium position, or where will it shift to when temperature is increased and when temperature is decreased? I want to leave it at the comment section. Very important. So now it means that an increase in concentration of what, of the temperature in what? Endothermic reaction. So you can say an increase in temperature. Sorry, an increase in temperature. I did an increase in temperature. So you can say an increase in temperature in endothermic what reaction. An increase in temperature in what? In endothermic what reaction. What will happen here? So when you increase temperature here, remember temperature is what is treated a lot as what? As reactant here. So you shift what to the product side. So an increase in temperature in what? In endothermic reaction. The equilibrium position we shift. We shift to the what? Product what side. That is meaning we shift forward to what? Product side. We shift what? Forward. Then you got to favor what? Forward what? Reaction. So what happened to what? Decrease. So when you decrease the temperature here, you move back to what? To the reactant. So a decrease a decrease in temperature temperature in endothermic what reaction. The equilibrium position will shift to the reactant reactant side. It's okay. That is it. So with this now, you can solve any questions that comes your way when it comes to what this one here.